Hello, everyone. My name is Pavel, and it is my pleasure to welcome you to our webinar on BDD with AppCode. We'll start with a really short presentation on what BDD is and what tools we'll be using. So, what is BDD? Well, BDD stands for Behavior-Driven Development, and really it's very similar to TDD. However, it also aims at answering one very important question. We can all probably recall that one moment when you decided, hey, I will start writing tests now. So you open up your IDE, you created your new test file with tests, and then, void. Your mind was empty. You had that one question lurking somewhere deep within you. What should I test? Well, in BDD, you shouldn't focus on tests. In fact, forget the word test. In BDD, you should focus on specifications, on examples, how your objects should behave. You should focus on behaviors of your objects. And that is what BDD is about. Now, let's quickly go through tools that we'll be using. We'll be using Spectra, which is a BDD framework. We'll be also using Spectra, which doesn't come bundled with Spectra, but it comes from the same authors, and it's a matrix framework. We'll also use a great mocking framework called AwesomeClock, and of course AwesomeClock, which works really well with AwesomeClock. And that's everything for the introduction. Let's do it. So we prepared a really simple app for you that doesn't really do anything at this point. And let me walk you through what is in this app. We'll start by looking at the AppDelegate, which right now only has one property, which is a UI window, as usually AppDelegates have. And of course, it has an application that finish launching with options where we create the window, set it up a little bit, and make it visible. We also have a SignIn view controller that has a login and password text fields, as well as a sign-in button. The implementation is pretty simple. It only has the action that is hooked up to the sign-in button, the tap sign-in button. We also have a xib that glues this all together. And of course, there is our sign-in service, which represents an abstract sign-in service that we don't really know about, but right now it doesn't really have any methods. So let's start by creating a first test for our AppDelegate. We'll name the test, of course, AppDelegate specs. Notice that I copied the name of the test right now, or the name of the actual class, and of course we want to add this to specs. Let's name it AppDelegate spec.m. And now I'll use a live template that you all can download from the repository Anastasia mentioned a while ago, which is called sspec, which stands for specs, the specification, and spec, well, it's a single spec. And now, as I press tab, the live template got expanded, and I can paste the name of the class that I just copied, which, as you can see, got also pasted in my variable declaration and in the place where I will allocate the object in a second. Now, when I press enter, I will move to my variable declaration where I can use auto completion from AppCode to name it AppDelegate. It automatically popped in my before each and after each method. And of course, when I press enter, it will move to place where I can allocate it. So let's just go alloc init. And there's our first test, well, not test, but first test file prepared and up and ready. So let's go back to our test class, the class that we'll be testing. As I said before, it only has one method that finish launching with options, which comes from the UI application delegate method protocol. And we actually want to write tests for that method. So in our describe block, let's write that application did finish launching with options. And now I'll use another live template that comes from the live templates we shared with you, which is SBEF, which stands for specs before each. And in that before each block, I'll just call my AppDelegate application did finish launching with options. We don't really care here about the actual application or the options here, so we'll just pass in. And there it is, our first before each block and describe block are set up. Now I'll use another live template, SIT, which stands for specs example block, which is an actual test. And in that test, we'll write that it should have a SignIn view controller as root view controller, as we want to show the SignIn view controller to users. And now I'll use a macro that comes from Spectra, which basically says that I expect AppDelegate window root view controller to be kind of SignIn view controller class. And that's our first test written. However, you should remember that when you do TDD, you should first make your test fail to ensure that it actually works. Otherwise, you can get a test that doesn't really test anything. And then you write your code that is not actually tested, and thus your tests are pointless. So let's run and see whether this actually fails. And of course, I want to run this as specs, not the app on an device. Let's change that. There it is. And let's do it now. And as we can see, our test failed. And we can read that it expected to have a SignIn view controller, but the actual value was nil. So now we can go to our AppDelegate and fix that. And of course, we can do this by writing self window root view controller equals SignIn view controller alloc init. And there it is. Now we can run our tests again to see whether this actually passed. And as we expected, our test passed and everything is up and running. Great. So now let's move to another class that we'll be testing, our SignIn view controller. Let's start by preparing tests. Notice that I copied the name of the class here to fill it in my live template. And again, I'll use the same as spec live template. I expand it. Of course, I will use AppCode's completion to name it, and of course, I'll call alloc init. And there it is, our first, another test class up and ready. So let's go back to SignIn view controller object, and let's think what is the most important thing that we should test here. Well, since it's a SignIn view controller, we should focus on the user actually signing in. So that is the most important action that the user can take here. And we see that we have a login text field and password text field, and of course a sign-in button. Well, a naive approach to writing tests is that I define a describe block that says tapping sign-in button. And in the before each block, I'll just call sign-in view controller, sign-in button, send action for control events, which is the default action that gets hooked up to an interface builder, touch insight. But there is one problem with approach like this. First of all, we cannot interrogate how the interface of our sign-in view controller looks like. In fact, I shouldn't actually care that there is a sign-in button here or whether it has a login or password text fields, because these are just implementation details. All we care about is that there is somewhere within the view controller's view a button that has a text sign-in, and when it is pressed, we get some sort of a callback to our sign-in service. And since it's an implementation detail, I'll move this to a private category so that it's not visible here. The same goes, of course, for password and login text fields. However, when I go back to my tests, I see that the SignIn button is no longer available, which means I can no longer use it. But we can use a really great trick to grab that SignIn button without actually knowing that there is a property or SignIn view controller that is a button with title SignIn. And let's see how we can do that. I'll define a method called specsFindButton with title. And here I'll pass a NSLocalized string SignIn. And of course, no comment. And this will return a SignIn button. Now, I named this method specs as I want to underline that it comes from specs and it should not be used in other places in the app. Now, the great thing about AppCode is that it allows you not to have your flow interrupted. If I didn't have AppCode now, I would probably have to go somewhere into my project hierarchy. I would have to find a place where I can actually create a category. I would have to create the category. There, I would have to write the signature for my method, implement it, and then I could go back to my tests. That takes a lot of time and is actually an interruption from what you wanted to achieve. And the great thing about AppCode is that I can just press Alt-Enter here, and it will tell me that it can create new category on UI view with method specsFindButton with title. How awesome is that? So let's do that right now. Of course, we want to name the new category specs, and we want to place it in a folder that I created before, which is under the BDD AppCode specs helpers. And there it is, our awesome category. Now I can change the name of the variable here to title to make sure it's actually looking how it should look like. And there it is, our awesome method. Let's go back to our test now and see how it looks like. Let's split this so that it's accessible from other tests or before each is blocked that are encapsulated below. Great, we have our SignIn button. I marked it as a block variable so that it can be assigned from before each block. Great. But now we'd like to fill our text fields with some dummy data to perform some assertions. But we don't have access to text fields as we removed them from the interface here. We could, of course, copy private interface of our SignIn view controller to our tests. But then again, we'd be actually exposing internal implementation of SignIn view controller. And we already decided we don't want to do that. But we can use the same trick that we used here to grab that text field. In fact, let's do that right now. We'll create a new method on view that is going to be called specsFindTextField with placeholder. And of course, again, we'll use NSLocalized string, and the placeholder will be login and no comment. And of course, we assign this to a UI text field, login text field. Of course, we split this. Again, we move it up here, format the code a little bit, and now, again, I can just Alt-Enter to create new method, specsFindTextField with placeholder. I'll correct this to be placeholder. And notice that it already placed my new specsFindTextField with placeholder method in the appropriate category. Great. And of course, now I can just make this variable block, and we can create a new password text field. And of course, we'll search for placeholder password. Great. Now, we can fill our login text field with some dummy data. And our password text field with some dummy data. But we also have to remember that we actually have to implement these two methods. So let's do that right now. It will be really simple. We'll use a great class that comes with Foundation, which is called NSPredicate. And we'll use NSPredicate with block. Here, we'll change this to a UI view, evaluated view. We'll define a UI button object that will initially be nil, and then if our evaluated object is kind of class UI button class, we'll cast the evaluated object to the button. And of course, we have to do a cast here, and we can return button current title is equal to string title. So we got a predicate that checks whether a view is a button, and if it is a button, it will check whether current title is equal to string. Of course, if it is not a button, then this will be nil, and this whole expression will return no, meaning that we won't get that object. So let's extract this variable into a predicate, and now we can just write that self subviews filtered array using predicate R. Predicate will get all the buttons that match this predicate or views that match this predicate, and of course now we'll just call first object. And there it is, we got the button with given title. Now let's just copy this one and paste it in here, as it's going to be nearly the same. But of course, we'll be looking for UI text field. I love how AppCode tells me that I might have made a mistake because I'm checking for UI text field class, and then it's I cast it to UI button. But let's fix that as well. It's going to be a UI text field. We'll rename this to text field. And of course, we look for a placeholder that should be equal to placeholder. There it is, our two great new methods up and running. So let's go back to our tests now that we have everything set up. The one last thing that is missing actually from the setup is calling the action itself, which is pressing or simulating that the button gets pressed by user. We could do that by just calling SignIn button, send action for control events, UI control events, touch up insight, which I mentioned before is the default action that gets hooked up to a UI button in Interface Builder. However, there is one problem that I really don't like with this approach. It is not exactly consistent with all the tests that you will have in your test suite. For instance, if you wish to simulate a tap on a UI bar button item, which is not a view, you cannot call this method send actions for control events, which is not great, and I like to have my tests kind of consistent. So let's create a class, or actually a category, that will have this method specs simulate tap. Plus, this is way more readable than just send action for control events, meaning that your test will have better readability. And of course, we want to create a category on a UI control, and we'll place that in our helpers. And now we can just create the spec simulate tap method, in which I'll just call self send action for control events touch up insight. Great. Awesome. So we have all the setup that we wanted to do in our before each block up and ready. But there is one more thing that we are missing. We want to assert that our SignIn service should be informed that the user wants to sign in with username or login and password. And if we go to our SignIn view controller, we'll notice that there is no property SignIn service. So let's fix that right now and create a read-only property ID SignIn service. SignIn service. And again, power of AppCodes comes in because I can just generate a initializer. And there it is, our initializer dedicated for signing in. Now let me just add a pragma mark here to separate this part, and let's go back to our tests. Now that we have a designated initializer, we should actually use it. So let's create a mock sign-in service. We'll use AwesomeClock for this, and we'll use a mock protocol. Sign-in service. And of course, we want to split this to make sure it is accessible from tests below. And here, of course, we want to use init with sign-in service, mock sign-in service. Great. Now we can do the actual test that we completed our setup. And it should tell its sign-in manager that user wants to sign in with login and password. And now we can just use the verify method that comes from AwesomeClock, verify mock sign-in service, sign in with login, fixture login, password, fixture password. There it is. Now, the problem here is that verify returns an object of ID type, and unfortunately, AppCode doesn't really know this, but we can quickly correct this, and we can go back to our class, and here we can just call self sign-in service, sign in with login password. And now we can just Alt-Enter to create new method on our sign-in service protocol. There it is, great. And now we can just go back. Now, you probably remember that a few minutes ago I said that you should always make sure your tests fail before you actually run them. And having this code here means that my test will pass in the first place. So we should definitely remove it before we actually run tests. So let's go back to our sign-in view controller specs. And of course, I can just auto-import the sign-in service protocol header. And we see that it is up and running here. And let's just run the tests now and see what happens. Great, our test failed. Awesome. Now we can go back to our sign-in view controller and make sure that our test actually passed. So let me just call self sign-in service, sign in with login, self, login text field text, password, self, password text field text. And let's see whether this worked. Hopefully it will. And it didn't. No, wait, it did. Awesome. Great. So now our whole test suite is up and running, and we have our first part completed, actually. Now we can.
Okay, so we have a couple of questions.
Yes.
Yeah, so first of all, there is some interest in live templates you are using. So maybe you can show the full list in preferences, just maybe explaining a little bit what they are for, so what is
awesome.
there. So.
Okay, so there is actually quite a few live templates that we're using. So they usually just, well, this is boring, so let's not show this one. This is a custom one. Let's go with this one. This is just a simple, after each block that will, after expanding, will automatically move you to content here, so you can type it in. The same works for before each. We also have one for it should behave like if you're using shared examples group. Of course, we have the one for context. Contexts are the same for well, they work the same as describe blocks, however, they have a different meaning when you read them. Here's, of course, one for describe block, one for it, or just a simple test. Of course, we have one for pending test. We also have one that is really great for shared examples group. We have the most advanced one for the actual tests, the test class. And of course, we have one for subject action that is really old, and it comes from Cedar. We also have one, the two for Spectra, which is just expect to expect something and expect not to. And that is basically everything.
Yeah, thank you, Pavel. So there is also some questions about how to get this. So as we said before, there is a link to the GitHub from Pavel that is included into your just webinar reminder. You can go there, download, and just import as import settings, like click File and then Import Settings and select the file that you download. And so you will get these live templates at your AppCode version. Also, there was a question about what was the shortcut to implement spec file template. Was it Command N, and what was the next step? So maybe you can just repeat a little bit that part.
Yeah, okay, so let's just create a dummy one. It's really quick, and I love how it works. I usually just press Command N, then I press F or Shift F, and then I press Enter. I usually type what I want to type, so let's just fixture test. Then I just copy this one. I usually paste it because I'm too lazy and it's faster. Then I just write spec.m. Then I press Enter, and in the new file, I'll just write spec, and then I use tab to expand the whole live template, and then I just paste the name, fixture test, then I press Enter to move to where I can name my variable. I use AppCode's autocompletion to help me with the name, which is usually great. Then I use the name fixture test. Then I press Enter again, and I move to a place where I can alloc init my object. And having this set is just really great, because what you saw was for tests that are written for objects that already exist. But if you're writing a new object, as you should with BDD and TDD, this is great because I can just Alt-Enter on this fixture test class and tell AppCode to create a new class in the same place. The only thing I have to change here is to assign it to a property target. And there it's done. And it's really cool, it's really simple, and it's really fast when you're writing a new object.
Okay, so thank you, Pavel. And maybe the last question as for now, that is, why not to use KIF for UI?
Yeah, so we used KIF actually for a very, very long time, and we learned that they tend to fail for reasons that are not exactly known to us, aka they worked for most of the time, but there were times where they just failed and everything was okay. So we decided to drop them, and we tried to have our UI tested with unit tests, which is actually okay, and it works for us. But that was a long time ago, and perhaps KIF has improved since that time, and it might be better now.
Okay, so thank you, and now let's pass to Lucas.
Hello everyone, it's Łukasz, and can you see my AppCode screen?
Yeah, Lucas, it's fine.
Okay, great. I want to talk to you today about, show you the demo about how to test the asynchronous actions in your code, in your project by using an AppCode. And we'll continue from where Pavel finished. Pavel went on the vacation, and we are left with this project. So let's see what's the current stage of the project. Let's start with running specs and to see if we can continue working on the project. Yes, everything is green, so we are set. Next step would be to check what's done in the project. So the good thing is to check the specification, and we can see that we have the UI wired with a view controller and the sign-in service. Great. And what I want to show to you is...
Lucas, can I just interrupt you for a minute?
Yeah.
There is just one question that is important, but could you increase the font a little bit, because the people would like to see more. Sorry for interruption.
Do you remember what's the shortcut for it, or maybe just...
Yes, you can do it from here.
Where was it?
Go to the appearance. It's in the IDE settings, or you can like tap font here. Yes.
Okay.
Thank you.
This one will be a little bit too big.
Yes, and sorry for interruption once more.
Okay, no problem. I hope that you can see it better now. Okay, so let's continue. So what are we going to test? We are going to test an action when the sign-in completes with a success. And to start doing that, we need to first go to the sign-in service and add the delegate property here. There's for a sign-in service. Let's add this delegate property. Okay, let's pre-declare it. We have here, and let's define it here. It's good for it to extend an as object protocol, and it will define only one method for now, which is sign-in service.login, and we will use that later for informing view controller that the action have completed. Okay, so let's come back to our specs and start to check how it's done. So as you have seen, Pavel used the mock for verifying that some actions were done on the and the specification was fulfilled. In our case, we need to substitute this mock with a fake object, since we are going to simulate some actions by this object. And the fake is a different type of the testable, and we will introduce that here. So we will create the class that does not exist yet. That's not a problem. We'll create this class, and it's only for the test purposes, so we will add it to the specs with target. Just create it, and we want it to conform to this protocol, and we want it to implement the defined methods and to synthesize delegate property. Okay, so we have this done here. We come back to our test. Let's refactor it a little bit, since it's no longer mock. It would be good to name it fake sign-in service. Okay, we have done refactored. Let's run tests. And our tests failed. And it's described that the argument passed to the verify should be mock, but it's type of the fake sign-in service. Of course, that makes sense. Since we no longer use mock, we have to rewrite our test over here. So what's actually this verify checks? It checks whether this method was called with past arguments. So we can do the same in our fake. To do this, we just need to capture both arguments, login, and also capture password. And creating properties is no problem in AppCode. And we are done here. We come back to our specs, and we, instead of using verify macro, we will use expect assertions and check whether our captured login is equal to fixture login, the same value that we used before, and let's verify that the password is as well fixture password. We can delete it and run our test. Okay, all the tests are running, or tests are passing, so we have a green light to continue. What we have done here, we have refactored our test code, and it is important to not to hesitate doing so, because it is important to maintain your test code as well as it is important to maintain your production code. So always keep it clean. So we are done with refactoring, so we can start writing our test. And I will close this pane. We will create a nested describe. We will use the live template that Pavel already introduced to you, and this describe will specify what a case when the sign in succeeds. And in the before each, we need to simulate this situation. We have action taken before, and next thing we want to simulate what happens when the sign-in succeeds. And this is where the fake actually comes in. And we don't have the method to simulate this action, but we can add it really easily. And like Pavel did it during his demo, let's start writing what we want to achieve here. So we want to simulate that specs, simulate success login. And create a new method. Let's fix typo. Okay, and our simulation it calls delegate only method to inform delegate that the sign-in did complete. And what we expect to happen, we want that alert view should be shown. So it should show an alert view to user. And how to check whether an alert view was presented? I have a helper category on the alert view already prepared together with the helper method that were presented before. So if we go to the alert view category, there is one class method that returns last presented alert view. And if you go into the implementation, in the show method, we just capture the last presented alert view. This is a trick that it's not recommended. Sometimes you may use it, but try not to overuse this pattern, and make sure that this code is not shipped with the production code. It's only for the test purposes. Okay, so let's make use of this method. We'll go to our tests. And let's extract this alert view to separate variable. And we want to expect that our alert view title is equal to sign in, and its alert view message is equal to did sign in. sign in. Okay, so we have this test. Let's run and okay. We need to specify what we want to achieve here, and let's hit run and check if the test fails. Okay, it fails, so we have to fix it. To fix it, we go to the implementation file, and in the implementation file, we have to wire things up. We need to set delegate for our sign-in service. We'll set self here, and we will adopt protocol okay. And as we specified before, we want to show alert view to user with title sign in and message did sign in exclamation marks. No delegate is needed over here. We only need one OK button and no other buttons. We'll extract this variable and we can show it. Okay, so now we can run tests. And it still fails. We have some problem here, probably the method. Okay, yeah. Yeah, we renamed here this method only here, and we can go back to fix that. Okay. Okay, great. We have all tests passing, so application should work. Let's go to and run it. Simulator is here. And nothing happens, no alert view. So is it the demo fail? Of course not. It's not the demo fail. It's what has happened. We didn't wire up our sign-in service in our AppDelegate. And what I want to point out here, even though we have an application with a suite of tests, it doesn't mean that we won't have any bugs in our applications. But we make sure that this bug won't ever happen again. So we will create a test that will verify that the sign-in view controller is set up with a sign-in service at the initialization. It should have, so let's specify that it should have a sign-in service set up. And we want our sign-in view controller extracted from window root view controller. We can cast it since it's tested before, and we want to assert that sign-in view controller's sign-in service to be kind of and we don't have implementation of the production sign-in service, so let's introduce it. Production sign-in service class. And we will create the new class of production sign-in service. We will place it next to our sign-in service protocol. We want to put it into our production target. This object should also conform to the same protocol and implement methods that are specified and synthesize delegate property. This production implementation will simply wait 1 second and call its delegate method. It's the demo production service. Okay, so we will go back to our test now, and let's go and run it. The test should fail now. It failed, so let's fix it. We go to our implementation file and we'll pass production service new instance to our SignIn view controller. And hit and run. Everything passes. So now application should work. And after 1 second, we have an alert view informing the user that he did sign in. And we can commit our changes, and we can continue working on adding additional functionalities like checking whether the text fields are set up properly, and more great features. One last thing I would like to show you, just to quick presentation, how to test the asynchronous code operation is to make use of async block in the Spectra. And I won't show you the demo over here, but I want to make sure that you know about this, that this block will actually, by using this block, you don't have to use the fake object. You just tell the Spectra to verify that those assertions that will be put here will be met, and the timeout for this async block by default is 10 seconds. And it's good sometimes to use for your legacy code if you don't want to change a lot of your implementation by setting the fake dependencies. But it has, of course, a drawback of making tests running slower. And slower test means feedback coming later. So that's everything that I wanted to show you. Thank you for your attention, and I will be happy to answer your questions.
Thank you, Lucas. So we have a couple of questions around the demo project. So the first is, wouldn't it be better to keep the pointer and object ID instead of the alert instance to avoid memory leaks and implicit problems with the next tests?
Could you repeat the question?
Yeah, so the question was about if it's better to keep the pointer and object ID instead of the alert instance, that is to avoid memory leaks and some problems with the next tests.
You mean about the alert view? We can, yeah, this is one of the approach that we can also do over here, and what we can also do to make to get rid of the memory leaks, we can add the cleanup over here.
You can
Yep.
You can create a method after each class
if
method.
It works also on the Spectra, yeah, of course. Then,
Spectra, yeah.
So after each method is called every time when the tests were completed, and it will simply clean the pointer over here. So you can also use it, and there is a companion method for before each. And you can
Spectra, when it starts, when the framework starts, it introspects all objects, all classes actually, in runtime and searches for objects that have after each or before each defined. And when it finds them, it saves them, and it calls these methods before and after each test.
Exactly.
So you can use that one to clean the memory up here.
Okay, so thank you. And the next question is, could you explain what verify does and what is mock? So the user just missed that part.
Okay. So we, oh, what's something that happened over here? What we did over here, I will revert those changes here because maybe this. Oh. Okay, I will go back here. So we replaced our our mock sign-in service with a fake sign-in service, and the mock was an object that came from the AwesomeClock framework, and the mock object is the simple object that records what happens on it, and at the verify over here you can verify that the exact method was called. We replaced that mock with a fake object, and we implemented the assertions ourselves. And if you would like to know more about the double objects like fake, stubs, mocks, and spies, there is a lot of literature in the about this, and it is really broad topic. And good starting point would be Objective-CIO latest article, and there is an post about this as well.
Okay, so thank you. And maybe the last question is about how Spectra is compared or relates to Kiwi.
So the difference is are really subtle. The main difference between the Spectra and Kiwi is that it doesn't come with the suite of matchers. It's just the framework for BDD and the syntax, and you can use, but it works really well with the Spectra and Hamcrest and other frameworks like AwesomeClock for testing. Kiwi brings their own framework. Also, we can use the other frameworks like the Spectra, but it also comes with their own matching macros. Is there anything else, Pavel, that I missed?
Yes, you missed the most important thing, at least from my perspective. But what you said is true. Of course, it doesn't compound it with matchers. And at the same time, it means that its implementation is really simple, which I love, because then I can just use other matchers framework to create my testing tool suite. But there is one great difference. Spectra allows you to focus tests, which means that you can run that only tests during your test run. Of course, the same thing is possible with Xcode. However, it takes way more time because you have to select a single test, right-click on it, just tap run this test, and then Xcode will run. Whereas in Spectra, you can just put F instead of in front of it. You can put an F in front of a describe block or an F in front of a context block, and then Spectra will run those tests only. Moreover, this will also work with command line, because if you want to run a single test from command line with well, the standard XC test, you have to create a separate scheme, and then in that scheme, mark that it should run that test only, which again is a little bit more of an effort, and in the end, it's all about time and how quickly you get the feedback.
Okay, so thank you both for the presenting.
Anastasia, can I extend an answer for one question?
Yeah, sure.
Awesome. So there was a question, why not to use Key for UI? And I'll be honest, I didn't really think when I said what I said, but I think there is a way better answer to that question, and I'd love to share it right now. I actually wrote it, but I want to share it with everyone. So again, it's all about time. Of course, you can have Kif test all the UI stuff, and you'd be probably okay. However, when you have your UI also, or the how your UI is hooked up, tested with Spectra, you get the feedback instantly. You don't have to wait for Kif to execute all the tests, to click through the application. You'll get all that stuff instantly, or in less than 5 seconds. And for me, that is really important, because I know whether I broke something almost instantly, whereas I have to wait probably a few minutes or a bunch of seconds to get that feedback. And for me, that just works better. However, I do imagine that you can get more or less the same amount of error detection with Kif. However, again, it will be slower.
Yeah, so thank you, Pavel, for your answer. So let me just show you a couple of useful information now, and then we are done. So if you would like to learn more, so just to learn more about AppCode, go to jetbrains.com/appcode, and feel free to provide any feedback to Pavel, Lukasz, or the AppCode team. As I said before, the video recording of the webinar will be available in a couple of days, or maybe even tomorrow, on our JetBrains YouTube channel, and we'll announce it via our social media and blog. So thanks everyone for joining us today. If you'd like to learn more about upcoming webinars, just subscribe to our Twitter. We will be happy to have you next time for the webinar. So thank you, and develop with pleasure.